All right, this is Honors Algebra 2 Pre-Calculus. We're doing 8.5 in Algebra 2, solving rational equations and inequalities, and this is our first video in the series. So when we solve rational equations by hand, it's generally much easier if we're dealing with a proportion. So that is a single fraction equal to a single fraction. Recall that if we have a over b equals c over d, that's called a proportion, as long as b and d are not 0, right, since you can't divide by 0, then we can cross multiply and say that a times d equals b times c. So we're going to use that principle to solve. All right, so we're going to go ahead and solve this by hand first, and then we're going to talk about how to solve it on a calculator. So since this is a proportion, right, a over b equals c over d, we can cross multiply and say that x times x minus 4 has to equal x minus 6 times 1, right? So x squared minus 4x equals x minus 6. And now see how I have different powers of x? That means that I'm going to have to factor to solve, right? So I'd move everything to one side so that one side equals 0. I'll subtract the x over to get a negative 5x, and I'll add the 6. And I'm going to get that this factors into an x minus 2 times an x minus 3 equals 0. So either x minus 2 is 0, which gives me x equals 2, or x minus 3 is 0, which gives me x equals 3, right? So that's what happens if we solve by hand. Now, I should check my work, right? The reason we want to check is because there are domain issues here, right? So sometimes we're going to get an answer that mathematically works here, but when we plug it in, it doesn't work because of the domain issues. So let's double check, right? So let's check x equals 2. So I'm going to do 2 over negative 4, and the question is, does that equal a 1 over a negative 2? Well, it does. Negative 1/2 equals negative 1/2, so that works, right? And we're going to go ahead and check x is 3. Right? When I plug in 3, I get 3 over negative 3, right? And the question is, does that equal a 1 over a negative 1? And sure enough, negative 1 equals negative 1. So those are my two answers, and I'm all good. All right, so now let's walk through how we would do this on a calculator. So it can be really difficult to find the intersection of two things in a calculator window. And the reason for that is that you sometimes have no idea where something intersects, right? And the xy plane is genuinely infinite. Right now, you're probably not going to get answers that are in the billions, but it's really hard to see where things intersect. So the best way to do this is to take this fraction and subtract it to the other side. So what we're going to do is we're going to do x over x minus 6 minus this fraction equals 0, and we're going to put this whole thing in as our y1, and then we're going to second calc 0. So let's go ahead and do that. When I go to my y equals, right, so I have an x divided by, in parentheses, x minus 6, right? Anytime something's not a monomial, I'm going to have to put it in parentheses on the top or the bottom of a fraction, right? 1 divided by, and then in parentheses, x minus 4, right? Once I have that, I'm going to go ahead and zoom 6, right? And now I'm just looking for zeros, right? So I see that it looks like there might be zeros here, but I can't 100% tell, so I'm going to zoom in a little bit. The way zoom in works is you scroll to where you think you want it to zoom, and then hit enter, right? And you can see that it's definitely above the axis, and then you see that little blip, it definitely dips below. So I'm going to zoom in one more time to get a better gauge for what's happening where this thing dips below the axis. And sure enough, there are two answers, right? You can see that it dips below the axis, so I'm going to second calc 0, right? I'm going to go to the left of that 0. Now, I always work from left to right, so I'm going to go to the 0 that's the farthest left first. So notice I'm below the axis. There you go. I'm above the x-axis. Go to the right of the 0. See how the y's are now negative. I'm below, and hit enter. Hey, look, there's x equals 2. Right? And then I'm going to do second calc 0 again. I'm going to scroll over. Still going. And we already know the answer is going to be 3 because we already saw it, but we're to the left of the 0, right? Then when we cross the axis, the sign on the y should change. Sure enough, it did. It's positive. Hit enter, and then guess. And then sure enough, there's my other 0 at 3, right? So just to drag those two shots here. 1, 2, right? So again, it's much easier. It's much easier to use second calc 0 than second calc intersect, because the idea is, and I wrote it up here a little bit too, is that if you use second calc 0, you know at least the y value of the intersection will be, or the y value that you're looking for is 0. If you use second calc intersect, you could be looking for literally any x and any y, and that can be really difficult. All right, so go ahead and try P1. We're going to solve by hand first, and then I'm going to have you try it on a calculator just to make sure that you have the skill. So feel free to pause me if you want. Obviously, some things don't factor, and you just have to use a calculator. Okay, so this is a proportion again, so I can do A times D equals B times C, right? So x times the quantity x minus 2 equals a 3 times a 1. X squared minus 2x equals 3. Because I have different powers of my x, I need to factor to solve. So I'll subtract the 3 over, and I'm going to get x minus 3 times x plus 1 equals 0. So either x minus 3 is 0, which gives me x is 3, or x plus 1 is 0, which gives me x is negative 1, right? And I should double check, because with domain restrictions, you should be careful that things work. So let's go ahead and check with 3. And I can expand on that a little bit. It would be pretty obvious if one of these violated the domain. So for instance, if I had gotten x is 2, I'd have a problem, right? Because 2 minus 2 would be an issue. And I didn't here. I got 3 and negative 1. But it's still a good idea to check these as the math gets harder. So sure enough, this is 1 is 1, which 1 equals 1, which is correct. When I try x is negative 1, I get negative 1 over 3 equals 1 over a negative 3, and that's also true. So those are my two answers. Now, if we wanted to put this in a calculator, right, what you're going to do is you're going to subtract this guy over. So what you're going to put in as your y1 is x over 3 minus 1 divided by x minus 2, and then you're going to second calc 0. Right, so let's go ahead and put that in our calculator. So I have an x divided by 3, right, minus a 1 divided by, in parentheses, x minus 2, right? And we'll double check that's right. And then we're going to go ahead and zoom 6. All right, and here it's much easier to see that there are two clear zeros, right? So I'm going to do second calc 0. All right, I'm going to go to the left of that 0. So I need to go down to negative y values in this case. I scroll across the axis so the y value sign changes, and then hit enter. Sure enough, there's the first one at negative 1, right? And then we'll do second calc 0 again. Now we want the other one, so let's just go all the way over. There we go. All right, so I'm to the left of the 0. I cross the axis so the signs change. Hit enter, and there's my other 0 at 3. So we get negative 1 and 3. Those are both of our answers. So let's just drag these guys over here. All right. Cool. All right. So those are our two answers. And we found them on a calculator. So again, it doesn't matter. I do want you to be able to do it by hand, but it's a good idea to make sure you have the calculator skill, because some things can't be solved by hand. All right. So sometimes we end up with a special case such that both sides of the proportion end up with identical denominators. If that happens, we can essentially ignore the denominators and recognize that if a over b equals c over b, then a has to be the same as c. Now there's a logical reason behind this, so let me just walk you through why that would be true. Let's say that we did, so it's great if you spot this as long as b is not 0, but let's say that we chose to actually solve this. So if we wanted to see why, if I cross multiply, I would get b times a equals b times c. I could then say, oh, I'm going to divide the whole thing by b and just get a equals c. But remember, this only works if b is not 0, right? Because you're not allowed to have 0 in your denominator. So again, if you have a proportion where the bottoms are equal, then the tops also have to be equal, right? All right, so here's why this is useful. In this case, right, we're going to solve this first by hand, and then we'll put it on a calculator in a minute. I notice that these denominators have a lot in common, because the denominator on the right-hand side is a difference of squares. It's actually both of these factors. So if I get a common denominator on the left-hand side, right, if I get a common denominator on the left-hand side by multiplying this fraction by an x plus 3 over x plus 3, and if I get a common denominator by multiplying this by an x minus 3 over x minus 3, it is not at all an accident that all three fractions have the same denominator. So I'm going to get that this is an x squared plus a 3x, right, because this is an x times this stuff, plus this will be a 2x squared minus a 6x, so 2x squared minus 6x over this nice common denominator, and that's going to equal the 18 over the exact same nice common denominator. So see how these are the same? These are exactly the same on both sides of the equal sign. Well, that means I can essentially ignore them and recognize that, oh, the numerators also have to be equal. So the numerators have to also be equal because the denominators are the same. Sorry, let me combine my like terms while I'm at it. Right, so if I combine my like terms, I get a 3x squared minus 3x equals an 18, right? So now when I go to solve, 3x squared minus 3x minus 18 equals 0. Take a GCF of 3 out. Right, and I'm going to get that this factors into an x minus 3, x plus 2, and you can double check me on that if you want. So now when I go to solve, either 3 equals 0, which is a lie, so I can ignore that, or x minus 3 is 0, which gives me x is 3, right? Or x plus 2 equals 0, which gives me x is negative 2. So I get these two answers, but here's the issue. This is why I've been telling you to check. There's a domain restriction. The domain of this thing is that x is an element of reals, but x can't be the two things on the bottom that cause problems. X can't be a plus or minus 3. So if we go back down to our answer for a sec, one of those answers is going to be a problem, right? So one of these answers, right, the two answers I got were x equals 3 and x equals negative 2, I think. Let's double check. Yeah, x equals 3 and negative 2. Well, this can't be an answer because of a domain restriction, right? If you try plugging a 3 in, you're going to get a 0 on the bottom, and you can't have a 0 on the bottom. You should still check that negative 2 works, but it's not an issue because of the domain restriction. So right away, 3 doesn't work because if you plug a 3 in to either this fraction or this fraction, you get a 0 on the bottom, and you're not allowed to have that. If you want to check with negative 2, you certainly can. You're going to get negative 2 over negative 5, right? Plus, this will be a negative 4 over 1. And the question is, does that equal an 18 over 6? Let's see, it's negative 5, right? So 18 over negative 5. So if we clean this up a little bit, right, this is 2/5 plus 20/5, sorry, minus 20/5, my bad, equals negative 18/5. And sure enough, that's true, right? Because this one's negative and the other one's positive. So yep, that's true, it's fine. And my only answer is x equals negative 2, because the x equals 3 would be a domain violation, right? It would be a problem with the domain. Now let's go ahead and do this in a calculator because we're going to get a little bit of practice. Oh, sorry, we'll do that in oh, I didn't make you do it in a calculator. We'll go ahead and do it anyway. So let's go ahead and walk through this in a calculator, right? So if we do this in a calculator, right, the easiest way to do this in a calculator is, hang on, screenshot this and take it down to the bottom for a sec. All right, so the easiest way to do this in a calculator is to move everybody to one side, right? So if we're going to do this in a calculator, what we're going to do is we're going to go ahead and move this thing over, right? So we're going to move this thing to the other side. So my y1 is going to be x divided by x minus 3 plus the 2x divided by x plus 3 minus the 18 divided by the x squared minus 9. So let's go ahead and put that in our calculator and see how we do. All right, so x divided by x minus 3 plus 2x, oh, my bad, 2x divided by x plus 3. And just to be clear, you should really put entire numerators and denominators in parentheses, but it doesn't matter as much when it's the numerator because PEMDAS will make it so that it works out, but it's a better idea to put your entire numerator if there's more than one thing in it in parentheses. It would have worked out in that case because of PEMDAS. It would do the multiplication from left to right, and that would be fine. But just in case, it's better to put it in parentheses. All right, so double check that it's right. We have an x over an x minus 3 plus a 2x over an x plus 3 minus an 18 over the x squared minus 9. We're going to zoom 6. All right, and sure enough, this is the 0 we want, right? We do second calc 0. We're going to scroll to the left of that 0, right? Enter, cross the axis again to scroll to the right, and then guess, and there's our answer at negative 2, okay? So again, that's just kind of the idea. You can definitely do this in a calculator. I guess we don't actually need the screenshot, so we'll keep moving forward. All right, so Okay, you can do the same thing, solve by hand first, and then you can check on a calculator, right? So it's not an accident that when you look at these two factors, the x minus 2 and the x minus 3, those are totally the two factors of the x squared minus 5x plus 6, right? So that's totally those two factors. So if I multiply this fraction by x minus 3 over x minus 3 to get a common denominator, and this fraction by x minus 2 over x minus 2 to get a common denominator, I'm going to end up with an expression that has the same denominator on both sides. So this will be a proportion with the same denominator on both sides. So I'm going to get an x squared minus 3x plus an x squared minus 2x all over this common denominator of x minus 2, x minus 3 equals a 3 over that x minus 2, x minus 3. So because the denominators are the same, I can make the mental leap that the numerators are also the same, right? Because that's how proportions work. So I have a 2x squared minus a 5x equals a 3. 2x squared minus 5x minus 3 is 0. So I know it's a 2x and an x when I factor, right? I see that it has to be a 1 and a 3 with opposite signs. So if I put the 3 over here, I get a negative 6x. And if I put the plus 1 here, I get a positive 1x. So negative 6x and positive 1x, that's definitely the negative 5x that I want. So either 2x plus 1 is 0, which is going to give me x is negative 1/2, or x minus 3 is 0, which is going to give me x is 3. Right? So those are the two answers I get, but then I need to go back up and look at the domain issues. So there are two domain issues here, right? So if we look at the denominator, the domain of this thing is all real numbers, but x cannot be 2 or 3, right? X can't be 2 or 3. So when I go back down here, I say, wait a second, that's a domain issue, right? I have a vertical asymptote at negative or at x equals 3, so I can't use that answer. So it should really only be the negative 1/2. It's up to you if you want to check. I am going to admit that it's not super fun to check fractions in these things. So if you want to check, you can. It's definitely not super fun to check a fraction in here. So what that means is that I end up getting that my answer is just x equals negative 1/2. You can check it if you want. I'm going to say that it's not super duper fun to do so. If I go to put this in my calculator, right? So if we go to check this in our calculator, let me erase here so that we have a little bit of room and I can drag this down. If we go to put this in my calculator, again, the easiest way to do it is using second calc 0, not second calc intersect. My bad. There we go. So the easiest way to check this in the calculator is to move the right-hand side over to the left, right? So the easiest option is to move this guy over to the other side. So I'm going to make my y1 x over the quantity x minus 2 plus x over the quantity x minus 3 minus 3 over the quantity x squared minus 5x plus 6, right? And then I'm going to second calc 0. So let's go ahead and do that. So x over x minus 2, I can kind of cheat and just type over my own work. And then an x over an x minus 3 minus, this will be a 3 divided by x squared minus 5x plus 6. All right, you want to double check it's all right. X over x minus 3. Okay, and then we can zoom 6 again to see if we see our spot in there. Okay, and there's our only 0, so we're going to second calc 0, right? And actually, it's pretty clear early on what it is, but all right, there we go. So positive y, cross below the axis, negative y, and guess, hey, there it is, that's our negative 0.5. So again, you could check it by plugging in the negative 1/2, but it was sort of a miserable thing to plug into that, so I just wasn't about that lifestyle. All right, and that's the end of this video.